Hello, good evening to one and all. Uh, Today we are going to see about lasers, introduction and simple differentiation between three-level laser system and four-level laser system. Then we are going to see about what is laser rate equation. These topics will be helpful to understand the contents related to the post-graduation second year photonics paper. Initially, we start with the topic what is laser. It's a simple question which all the peoples come across from their higher secondary school level. Laser is a device that emits light which has a high intensity coherent nature, and this particular light has been achieved by means of amplification. So the acronym of laser stands for light amplification by stimulated emission of radiation. Here we need to note that a light emitted by means of amplification through the process called stimulated emission as a radiation. So combining all these aspects as a formation of light amplification by stimulation emission of radiation stands for laser. Next, we are going to see what's the difference between three-level laser system and four-level laser system. For example, if we talk about the laser systems, a laser can be classified into many types by means of many parameters or many facts. For example, if we take the three important stages which we need to achieve the lasing action, we initially start with the active medium. The active medium depends upon the quantity or the type of active medium what we are going to utilize to achieve the laser can helps us to define what kind of laser it is, what type of laser it is. It has many types like gas laser, semiconductor laser, solid laser, ion laser, dye laser. There are many kind of laser which is differentiated by means of the type of active mediums utilized to achieve the laser action in the laser cavity. It's one type of differentiating or the one kind of splitting the laser type by means of utilization of type of active medium. We are not going to see that kind of content today. We are going to see how this lasing action is going to be achieved by means of energy states. By means of energy states, we are going to differentiate the lasers in two types. The one is three-level laser, another one is four-level laser. For a general perspective, for a simple man understanding, three-level laser systems and four-level laser systems nothing but the laser need to be amplified and need to be achieve the population inversion by means of three energy state helps us to construct three-level laser system. If it is achieved by means of four-level energy states, we call it as four-level laser system. Here we have shown two kind of energy system diagram. The one what I am shown here is three-level laser system, and the one shown here is four-level laser system. If you look upon these two diagram, from that we can easily understand that the laser system consists of three states. The first one, E1, is nothing but the ground state. E3 is nothing but the excited state. E2 is nothing but the metastable state. Mostly the atoms pumped from a ground state to excited state by absorbing the photonic energy in form of optics or in form of electrical energy, electrical sources, or in form of arc lamps, and it moved from E1 to E3. We know that the lifespan of the atoms or electrons at the excited state is very, very less. So they are always looking upon the more stable state compared to its original state. Okay, so it's moved spontaneously by means of spontaneous emissions from the excited state to the next metastable states, where it has the extra bit of lifespan to achieve that population inversion. From there, when it is moving towards its original ground state, where it has a long-lived life, it emits laser lights. Comparing this 3-level laser system, a 4-level laser system have one more energy states in between the E2 and ground state. This virtual energy states helps us to achieve 4-level laser system. Both this 3-level laser system and 4-level is commonly used in many kind of applications in day-to-day life, from commercial usage to industrial applications. Let's we are going to see what is laser rate equation. Particularly, what we are going to see about what is 3-level laser rate equation. Okay. We can start from the laser rate equation for a 3-level laser system. Here I have shown again a 3-level laser system energy level diagram here. We can call 3-level energy states called E1, E2 and E3. The number of atoms are populated in these 3 states represented by the words called N1, N2 and N3. First, before entering into the mathematical treatment, let's look upon the basic idea or basic procedure or basic is fall upon this 3-level laser system to achieve lasing action. Okay. Initially, while we are supplying the energy by means of optical or by means of electrical source to these atoms available in the energy E1, energy state E1, this will absorb the energy and excited to the energy state E3. Okay. Then from there, the number of atoms keep on increasing to a certain limit. They will start jumping, or we will start to transmit from E3 to E2 by means of spontaneous emission without radiating the laser. Okay. So finally, once the pumped atoms from the ground state reached the E2 state by means of spontaneous emission through pumping process, the number of atoms keep on rising at the E2 state in an anonymous way. Finally, we are achieving that population inversion condition after supplying the required minimum required amount of energy as pumping energy to the atoms. We will end up with achieving that population inversion at the E2. So the required number of atoms achieved in the E2 will start to transmit from E2 to the ground state by means of spontaneous emission. That spontaneous emission helps to initiate, helps to kickstart that stimulated emission. So these two combinedly give us the lasing action, which helps us to achieve the required laser output. Okay, this is what the whole idea about this lasing action in 3-level laser system. The equation what I have mentioned here, N0 is equal to N1 plus N2 plus N3 is nothing but the total number of atoms available in all 3 states has been mentioned as N0. By sum up of all 3 states will help us to achieve the same. Okay. Next we are going to see the rate of change of atomic density at different levels in E1, E2 and E3 by means of equation 2, 3 and 4. Okay. We look upon the equation 2, dN3 by dt. We used to say d of something by dt is nothing but rate of change of something with respect to time. Okay. Here we have mentioned dN3 by dt, which means the number of atoms available in the E3 states going to be populated or going to be decreased by means of its own transition with respect to time. Is denoted by the combination of 3 terms. If you look upon here, we have 3 terms. Okay, these 3 terms is nothing but it's a representation of the transitions happen from E3 state to E2, E3 state to E1. Let's look upon the 3 transitions happen in the E3 states. Initially, it has one pumping. The pumping helps us to achieve enormous number of atoms from E1 to E3. So it's a transition towards E3. Then there are 2 transitions, 2 spontaneous emission transitions. One is from E3 to E1, another one is E3 to E2. Okay, so those 3 transitions has been mentioned here. The first one belongs to the pumping one. This WP is nothing but the work process through the pumping process, work done by the pumping process to move the atoms from N1 state to N3. Since it is towards that particular state is we treated as positive. These two transitions are taken the atoms from E3 to other states. So we are treated as the negative terms, which means these two actions reduce the number of population of the atoms in the N3 state. The first one is helps us to achieve the number of atoms in the E3 states. So what are the transitions helps us to increase the number of atoms in that particular states mentioned as the positive value, and the actions or the transitions helps us to reduce the number of atoms in the particular states mentioned as the negative terms. Okay, this is what the whole idea about is. Like that we are writing the rate of change of atomic density in E2 and E3 in a similar way written here, okay, and mentioned as equation number 3 and equation number 4. Under the naturally steady state condition, these three rate changes has some conditions, dn3 by dt equal to 0, dn2 by dt equal to 0, and dn1 by dt equal to 0. Finally, whatever the energy given to the number of atoms which absorbs and excites, after some span atoms directly go to the ground state. That's what this steady state condition means. Okay, by taking these three particular conditions, applying these three conditions to the above equations 2, 3 and 4, from equation 2, if you look upon the equation 2, the left hand side becomes 0. So from the right hand side terms has been rewritten here as our requirement. If we look upon here, we have Wp multiplied with N2 and N1 and N3. So we are multiplying this Wp inside this bracket, and it has been reduced like this, and there will be no change in the right hand side. Again now I am going to relocate this negative term Wp N3 to one right hand side, which has three common terms, common multiplication as N3. If you look up here, N3 multiplied here, N3 multiplied here, N3 multiplied. So I am grouping them on right hand side. Okay, so finally we end up with N3 is equal to Wp by Wp plus A31 S3 into Tn1. Okay, this is mentioned as equation number 5. There are two coefficients used in writing this set of equations. One is A32 and S32. Both are spontaneous emissions, but A32 helps us to achieve non-reductive transitions. S32 helps us to achieve stimulated emissions. Mostly it helps, this S32 transitions helps us to achieve lasing actions. Okay. From this we are rewriting the above equations by considering these particular conditions. A31 is very less compared to S32, so we may able to omit that term A31. So we are removing this A31 by utilizing this condition, and we are rewriting this equation as in a simplified form like this, and it is mentioned as equation number 6. As how we are using or applying the condition and that steady state condition equation 2, like that we are applying the steady state condition equation 3. The left hand side becomes 0, the right hand side equations can be taken like this, and we are simplifying it by multiplying the common terms into the brackets and collecting the common multiplies in one side and rearranging them according to this and according to our calculations. Okay, if you, this is not a rocket science. Okay, anyone can sit and simply solve by rearranging the negative term to the right hand side, this negative term to the left hand side. So this negative term A21 N2 while moving from left hand side to right hand side becomes positive. Like that, this W21 N1 from the left hand side will move to the right hand side. This negative term while moving towards right hand side will become positive. Okay, after that we are just relocating the required terms in a proper way as mentioned here. Now we have the N2 by N1 formula. If you look upon here, the N21 by N1 has been arrived. By taking the number of atoms available in the N2 state to the number of atoms available in the N1 state. Okay, the two states will help us to achieve the population inversion. Now we are going to do a small mathematical trick, or we are going to do a small mathematical calculations by subtracting the denominator in the numerator and dividing it by the same denominator. Okay, for example, I have n2 by n1 here. I am going to subtract the n1 value in the numerator and going to be subtract by the same value of denominator. Okay, this is what mentioned here. And while doing this simple mathematical calculation by taking this denominator, subtracting with the numerator, again dividing with the same value, repeating the same on left hand side also, we are ending with this kind of results. Once you sit and do this calculation on your own, definitely you can achieve these particular things. I have verified it with multiple times and I have achieved the same kind of results, so there will be no doubt in this derivation. If anyone have any doubt in the particular step, you can just comment me in the comment box. I will try to add up this derivation in the future video contents. Okay. Now we are going to see about the minimum pumping rate equation. WPT is equal to S32 A21 by S32 minus A1. Okay. This is derived by means of a laser process. Okay. So achieving this particular equation has many logical works behind the lasing actions. You can take as it is. Okay. From this, there is a condition like we know that A21 is always less compared with A31. By comparing or by utilizing this condition, this particular phenomena can be rewritten like this. So under minimum threshold condition, which indirectly tells us that the required amount to achieve population inversion, the minimum required amount of energy helps us to achieve population inversions, can be written as WPT is equal to A21. Okay. Substitute that n3 value which we derived from equation number 6 on this equation. Okay. Here we are substituted with this particular formula. We are removing that n3 instead of this equation and replacing that n3 in this equation. Then we have the common multiple is n1 and taking that n1 and simplifying on left hand side as keeping the same as it is in the right hand side, we are obtaining this n2 by n1 again. Okay. As we did, how we are taking the denominator and subtracting it in the numerator and dividing it the same. Now we are going to repeat the same with the sum up action. We are going to take the dividend, going to add up with the numerator and dividing with the same denominator, and end up with this big equation. This again is derived by me many times through hand calculation, and I achieved the same. So if anyone have any doubts, you can comment me. I will help you to achieve the same through some other videos. Okay. Now we have two important equations, so equation number 7 and equation number 8. Nothing but the difference in n2 and n1 and the sum up of n2 and n1 going to be divide this equation 8 by means of equation 7. This helps us to achieve n2 minus n1 by n2 plus n1. By making simple calculations, we are achieving the right hand side results to equate this n2 minus n1 by n1 plus n2. There are three stages in achieving this population inversion. One is below the threshold value, at threshold value, after threshold value. Below the threshold value, we are in the process to achieve population inversion. At threshold value, we are entering into the lasing action. After the threshold value, we are emitting that lasers. Okay, so we have to see the difference in these three stages. So below threshold value, the work done to achieve that population inversion. Before that achievement of the population inversion, the number of atoms available in the E2 state is very less compared to the E1 state, because we are trying to pull over the atoms from the ground state to E3 state. Okay, this is what the initial things going upon while achieving the laser process. So during that time, the number of atoms available in E2 is very less, so compared to E1. So the work done to transit electrons from E2 to E1 is very less. That's what mentioned here. So taking this and simplifying this equation by removing the W term or replacing the W21 terms as 0, we are end up with this term. Okay. Now we are taking this S32 and S32 as a common multiplied in both denominator and numerator in right hand side. We end up with these three equations. We know that the spontaneous emission helps us to achieve non-radioactive transition is more high than compared with the transition from A2 to A1. So applying this particular term is going to be neglected. Finally, we end up with WP minus A21 by WP plus F21. If you look at this WP minus A21 by WP plus A21 available equation, more or less same like this left hand side equation, N2 minus N1 by N2 plus N1. Is the way it is written, the way it's arrived, it look like same as left hand side. So the left hand side, right hand side equations have the same kind of treatment of mathematical treatment. So we may compare them and write in such a way that N2 by N1 is nothing but is equal to WP A21, and we also rewrite the same condition in a suitable way, like WP N1 is equal to A21 N2. Okay. Now we are going to write the necessary condition for laser to oscillate. It is nothing but the lasing actions. For that we have two conditions. The N2 minus N1 must be a positive one. The number of atoms available in the E2 must be greater than that of the E1. It's nothing but the population inversion condition. So this must be positive. Okay. This must be positive. This, if it is positive only, we may able to achieve lasing action through this three-level laser system. We may rewrite the same condition like this also. The ratio between N2 and N1 is always positive 1 or greater than that of 1. Okay. These are the simple assumptions derived from this laser rate equations. Next, we are going to see about threshold pumping power. Okay. Threshold pumping power is nothing but it's given by the word called P. Okay, P is equal to WP N1 H nu P. Before that, we have to see what is WP N1. So the work done by pumping process to move the atoms or electrons from N1 to N3. Okay, that the minimum amount of energy to move the atom from E1 to E2. The number of atoms pumped from E1 to E3 by second by unit volume. That's what given by this two term. Nu P is nothing but the pumping frequency. Pumping frequency means the atoms, the photons frequency which is coming out to pull the atoms from E1 to E3 by means of pumping process. Okay. So that minimum amount of power required to pull the atoms from E1 to E3 is nothing but WP N1 H and nu P. This H is nothing but the Planck constant, nu P is nothing but the external photons frequency, N1 is the number of atoms available in the ground state, WP is the pumping process, work done by the pumping process. Okay. By utilizing that condition, power threshold condition, it helps us to write that WP, the work conditions, which is almost equal to A21. That's why we are replacing this WP by A21 and rewriting this P as threshold power P. Okay. And we know that even though we are pulling that atoms from E1 to E3, after some span of time the atoms move from E3 to E1 by means of spontaneous emission. Okay. So by means of spontaneous emission, the atoms keep on moving from the low lifespan excited state to high lifespan metastable state. The atoms keep on moving from E1 to E2 indirectly by means of E3. Okay. So the presence of E3 is almost nullified, okay, to achieve that population inversion. So we are treating that N3 as 0 in the initial condition. The total number of atoms N0 is equal to N1 plus N2, N3 is going to be rewritten in form of only considering that N2 and N1 in laser 3 equations. Okay. So N0 is equal to N1. From this, we are going to understand that number of atoms in the ground state is much more compared with the other two states. So the rating is N03 is very high comparing with the difference between N2 and N1. From that, we are rewriting that N1 and N2 almost half of the ground state atoms. By taking that PTH, threshold power value from the previous slide, and lifespan, we are going to rewrite the A21 coefficient form of lifespan is nothing but 1 by tau of Sp. Okay, it's just a symbolic representation of understanding how the atoms has been utilized. Atoms have to be stayed in the N2 state to N1 state by means of achieving this population inversion. Okay, By supplying these two values in the PTH value, we are achieving this threshold power pump formula. So these are the whole mathematical treatment available, required or discussed with this 3-level laser rate equation. Okay, if anybody has any doubt in any particular step, you may ping me through the comment box. I will try to answer it as soon as possible in form of short videos. Thank you very much for listening me, and I will try to give more videos like this in upcoming future. Happy learning. Thank you very much. Namaskar.